All right, so at this time, you should have already seen the first instructional video, and you should have already had an opportunity to try to make a hypothesis on what your solution to this third example is going to be. And so I'm going to go ahead and work through this, and we're going to highlight a couple things here as we're working through. And the significant difference in this problem is the fact that now we have two radicals on one side of the equation. And actually, what I'm going to do first is I'm just going to manipulate this equation so that way I have one radical on each side. I did that simply by going ahead and subtracting the square root of x minus 1 to both sides and subtracting 4 to both sides. Now, I did that so that way now whenever I square both sides of the equation, I'm going to go ahead and get an inequality statement that's going to have one radical rather than two. So as I stated before, I'm going to go ahead and square both sides. I got to make sure that I'm careful whenever I'm squaring here, because whenever I square the left side, that's going to result in x minus 8 square root of x plus 16. So again, remember that I am not allowed to distribute the two, and I'll end up getting two terms of negative 4 times x. That's where the negative 8 comes from. So a couple little things to watch out for there when you're multiplying, or in other words, when you're squaring. And then on the right side, that's going to result in just an x minus 1. Now from here, something nice actually happens for me is the fact that I just see I have an x on one side and an x on the other side. That's nice because if I subtract x to both sides, that's going to basically eliminate a variable of x, which now I just have a radical to go ahead and try to isolate. So in doing so, I'm going to leave negative 8 square root of x on the left, and this would be less than negative 17. And it's going to get a little messy here, but I'm going to divide both sides by 8, and that then is going to result in square root of x is less than 17 over 8. Now, I'm not done yet because I have to square both sides, and upon squaring both sides, it gives me x is less than 289 over 8, which, again, is kind of a messy number. And whenever I'm doing this, I might be, tempted to just be like, whew, I got the answer. I'm going to go ahead and stop right there. But a little red flag moment here is, again, given that we have the less than symbol right here, that's telling us that technically our answer right now is saying we're going from negative infinity to 289/8, which is approximately 4.52. But the red flag again comes up because, wait a second, I know I can't substitute negatives into here. Because if I put a negative in, that's going to give me a negative in my radical, and that's illegal to happen. So now I'm thinking, all right, wait a second, I caught the red flag. I can't go to negative infinity. I got to go from 0 to 289 over 8. But if that's my answer, I'm close, but still not right, because not only do I have to satisfy this first radical, I have to satisfy the second radical as well. And I can see that if I look here, I'm not allowed to put a number between 0 and 1 in, because that would also result in a negative. So finally, that leads me to my right answer of having, let's just go ahead and put that in blue. We're going to go ahead and say this would be from 1 to 289 over 8. That is going to be our solution set in this case, because not only did we have to satisfy the inequality, but we had to satisfy both of the radicals to make sure that the x values we're substituting in doesn't cause an imaginary value to occur. So just a couple things to look for. So just scanning back through, some of the easier type of scenarios for us to go through is whenever we just have one radical and it's a greater than a positive value. So that's going to be a real nice scenario for us. One of the look fors is going to be if we have a less than. That's going to tell us that we're going to end up having a domain to go ahead and verify that it's correct. So that's where we ended up with the 2 to 5. And then the final look for, or hardest scenario, is going to be if we end up having a less than symbol with two or more radicals. So not only do we have to solve the original statement, but we have to make sure we satisfy every one of the radicals. So with that, as you can see, I actually accidentally circled the wrong answer to that last one. This would be the correct answer there.